Alright, let's take a look at the Module 5 problem set. I've spent all morning looking at this and decided to make it a little bit easier than before, because if it's confusing me this much, then it's probably a more than optimal level of difficulty. So I scratched out the percentage tax requirement, but let me just give you a very quick graphical explanation of what that would look like. So if we've got a regular supply and demand, and then we throw in an extra percentage onto the amount of money the consumer has to pay, right? So like sales tax, it's $100 on the shelf, it's $108 on the bottom of your receipt. In a case like that, one simple way to model that would just be to rotate the supply curve up so that here 5% on $10 is 50 cents tax. 5% on $100 is a $5 tax, so we've got a $5 gap instead of a 50-cent gap. Now, that said, we are going to skip over the stuff that we've seen from last time. This is me just filling in some gaps on the price control aspect of this question. So finding the equilibrium price and quantity should be a piece of cake, and doing the same thing with a per unit tax also should be pretty simple by this point. You've done that a million times. You've got formulas in your notebook. So I'm not going to spend extra time on that right here, but of course, if you've got questions, feel free to ask in the usual places. Now let's talk about what I mean by minimum deadweight loss for my binding price floor or price ceiling. So I'll go ahead and draw a graph for each. So if we've got a binding price floor, that is a legal minimum price that is too high given the underlying economic reality that we're facing. So given that, we've got this high price, people would love to sell a bunch, right? So if the minimum price for mowing lawns was $1,000 a lawn, I would be happy to go out and mow lawns. But I'm going to have a hard time finding customers. So the binding constraint there is that we're just not going to find enough people willing to pay for this service at this high price. Now, given that, we've got quantity demanded over here, but our potential supply is this whole section of the supply curve. Right? So here we've got high school kids looking to raise a few bucks. Here we've got some people who could be getting a job somewhere else, but they're willing to do it for the right price. And then here you've got me. I'm willing to do it for $1,000, but I'm not willing to do it for the market price. Now, hypothetically, if you're looking for someone to mow your lawn, if a high school kid comes by to do it and they offer a low price, that's great. But if they're saying it's $1,000 per lawn, you're going to be a little skeptical of their ability to do a good job and to do it reliably because, high school kids, they don't have any work experience. You don't know that they know the right things. But then if some guy comes up with, a whole truck full of super advanced equipment, it's all shiny and new, that guy has higher costs, but since you can't pay less for the lower cost supplier anyways, you might as well go with the higher cost supplier. Right? Or if you imagine, say, a minimum wage of $25 an hour, Taco Bell's not going to hire high school kids, but at $25 an hour, they're going to find people whose opportunity cost is relatively high because they're good workers with good references and a work history, and the result is going to be that instead of getting all of this producer surplus down here, we're going to get this amount of benefit to the market, but at this cost. So the result there is we're going to be adding this green parallelogram of extra dead weight loss. Right? So that's an extreme story where we're only getting the highest cost sellers, but given this high minimum price, that is a possibility. Now the minimum, our best case scenario, is this red triangle. That red triangle is what we have to get given this minimum wage. As long as supply and demand don't shift, which is a realistic additional story we can tell at the end of this video, But at a minimum, we have to be getting this deadweight loss. Similarly, for a maximum price, our binding constraint is our quantity supplied, and as long as the good goes to the highest valued users, so let's say gasoline after a hurricane, ambulances get the gasoline, I don't get the gasoline to run a generator to play PlayStation. That is not an impossible situation, though. If gas only costs $3.50 a gallon and I've got nothing better to do, if I see the price at $3.50 a gallon, I might say, you know what, it's worth it to run the generator to play the PlayStation, given that low price. So if I just happen to get to the gas station first and the ambulance gets there later, then in that case, we again have all this extra deadweight loss over here. But our best case scenario, where magically the ambulance drivers get to the gas station first, our minimum deadweight loss is here. So how are we going to estimate that deadweight loss? Well, we need to know base times height times 1/2. Our base is going to be down here. We'll call that delta Q, the change in quantity. So we're going to find what is Q star, which you will have already solved for the first part of this problem for each of these models. And then we need to know this gap at this quantity. So for this, once we find the quantity, we plug it into the supply curve. We call that PS. We plug it into the demand curve. We find PD. Now for the linear models, it's just a triangle. If we're looking at the quadratic models, in that case, it's going to be a little bit messier. Right? In that case, we would need to use integral calculus, which we're not going to worry about. That's an advanced topic, although I guess we could have Wolfram do the hard work for us, but we're not going to worry about that. So, at the end of the video, let me just give myself a quick note. Breaking the Ceteris Paribus assumption. So, what is our outcome here? Let me find the marker I want. We're again going to say QD equals A plus B times P. QS equals C plus D times P. Now last week we had it slightly different. We had P equals, I'm going to call this capital A plus capital B times P. This A is not the same as this A, right? When we rearrange this, we're going to have quantity divided by stuff. So we can't just substitute these neatly in. We're going to have to do the algebra again. So given this, what we can plug in here is we'll find our price floor, and then we'll find our price for supply. And then here, actually I said we plug in this quantity, but we don't even have to for supply. This is going to be the price ceiling. So let's go ahead and look at the price ceiling. It's going to be very similar when we flip to the price floor, but we'll start with the ceiling. So, given this, we're going to have some quantity, and that quantity, let's go ahead and just say delta quantity is going to be, delta quantity with a Q, is going to be Q star minus, in this case, the quantity when we plug the price floor into the supply curve. So this is, let's use brackets, C plus D times our price ceiling. And our equilibrium quantity, that is going to be, let's see, how do we do that? So before I set up for this video, I was solving for an equilibrium price and then plugging it back into one of these, and that was a little bit of a pain, but we can do that. All right, so Q star. Let's just not lose this. Q star. We can do this a few ways. So one way is we can take these, set them equal to each other. A plus BP equals C plus DP, and then we solve for P, and then we plug it back into either one of those. So let's go ahead and do that. So BP minus DP equals C minus A. Took care of the A, took care of the C, took care of the BP, took care of the DP. Factor out the P. B minus D equals C minus A. P equals C minus A over B minus D. And Q star equals, plug this into either one of these. It really doesn't matter when we're not dealing with the problem with the tax. So let's call this A plus B times C minus A over B minus D. Oh, you know what? Scratch that. Since we're using C and D up here, this is going to make our job a little bit easier when we find delta Q. So for delta Q, here we've got Q star, so we've got this minus this stuff, right? Whatever PC is. So this minus this, we're going to have the C cancel out, and then we're going to have a D we can factor out. So delta Q over D, I'm going to divide both sides by D just so I'm dealing with this, is going to be C minus A over B minus D, right? This is P star, minus our price ceiling, whatever that happens to be, and so delta Q equals D times this whole thing, right? P star minus PC, where P star is this figure over here. All right, so we found delta Q. Now we need to find what is the price when we plug Q, when we plug this, well, not this, when we find, let's call this Q ceiling, is going to be C plus D times the price ceiling. So we plug this figure into our demand curve. So since this is a quantity, we put it on the quantity side. So we say C plus DPC equals A plus B PC, and we're P on the demand curve, and we're going to solve for that. Right? So if this is 10, then we can plug that in, and we'll find something. Now it's the P that matters, so let's go ahead and move this over. We're going to have P. We're going to end up dividing out the B. I'm running out of space, so I'm skipping some steps here. But this PD, this price, is going to be equal to this stuff, C plus D times our price ceiling, minus A. Right, we move that over, all divided by B. So whatever PC is, we plug that in, we find this, and then we can just say this price minus the rest. We can fit that down here, right? Let's switch colors just so it's obvious. Our deadweight loss equals PD minus PC, right? The price on the demand curve minus the price ceiling, times delta Q, which we're finding here, all divided by 2. We'll plug that into an Excel model in a moment. Let me show you this the other way. So if we've got QD equals A plus BC, BP, sorry, I'm dyslexing a bunch here. I've been doing a lot of algebra this morning. QS equals C plus DP. We want to find the Q's, right? So we're going to look at the floor here using an alternate approach. So how do we do this? Let's rearrange these terms so that it's P equals something. So if we say QD minus A equals B times P, that's a B. P equals quantity demanded minus A all over B. Right? Or we could say this is 1/2 QD minus A over B. Right? So notice 1/2, did I miss something? Not 1/2, 1 over B. 1 over B times QD, that's a B. 1 over B times QD minus A over B corresponds with this capital A and this capital B. Right, so capital B is 1 over B. Capital A is negative A over B. Right, so you can't just swap them out given a model specified in this form. You got to do a little bit of rearranging to get it right. So we're going to have that price, and then we're also going to have the price in equilibrium for the supply curve is going to turn into quantity supplied minus C over D. Right? Same basic thing, same basic steps to get this. We're just subbing out A and B for C and D. So we've got that. Now we want to find what is the equilibrium quantity. So we say price equals price, and then we solve. So here's the price on the demand curve, which must be equal to the price on the supply curve in our equilibrium. Now we solve for Q, right? So we're going to also substitute quantity demanded equals quantity supplied. QS equals QD, and we're going to rename that just Q. Technically Q star, but I'm going to be lazy and not write out the star. All right, what have we got here? How do we rearrange this? So we're going to have QD minus A times D. Oops, I already did that. Let's scratch that. Equals Q minus C times B. DQ minus DA equals BQ minus BC. DQ minus BQ equals, add DA, becomes a positive DA minus BC. Factor out the Q, D minus B, and we get Q equals DA minus BC all over D minus B. Cool. So we found our quantity. This is Q star. What do we say? DA minus BC all over D minus B. Right, given this initial setup and doing a little rearranging. And that's a little bit more direct in this case. So now we find what is the quantity that we get when we plug in the price floor. Well, that's the quantity on the demand side. So it's just going to be A plus B times PF. And then we plug A plus B times PF into the quantity on the supply side. And then we solve for this bottom P. And the difference gives us the one side of our dead weight loss. And then our delta Q, we could just do the way we've got here. I'll leave the rest for you to do in your notes. But big idea here is rearrange so it's in terms of P equals some function. You can solve directly for Q that way, or you can get to the same thing this way. Now, I've already been going for 19 minutes, so that's a lot to listen to, so let me give you some econ in addition to this. So if we've got, let's say, some minimum price. So classic story here for any aviation majors is the Civil Aeronautics Board. This was the regulatory agency that kept the price of airline tickets high in the mid-20th century. Jimmy Carter deregulated that industry and made flying interstate affordable to common Americans, so good for him for that. So if we've got these high prices, you've got a lot of potential quantity supplied relative to the quantity demand. You're not allowed to try and pick up customers by lowering your price, so what do? You add amenities. You compete on quality instead of on price. Now, if you do things like, say, add legroom, you might as well, if you've got a half-empty plane, pull out half the seats and people have more legroom. That's going to increase the value to consumers and shift demand to the right, but it's also going to mean that you're facing higher opportunity costs of selling your product, so we're going to shift supply to the left. Right? So whatever amenities we're adding, softer paper towel, less scary toilets, better customer service, we're adding some benefits, but we're also adding some costs. And in doing so, we're closing that gap. Now, the result could be that we get rid of the excess supply, right, or the surplus. And in that case, it's going to look like, hey, there's no problem. But notice the way I drew this. Our equilibrium fell because the benefits we're adding, let's say, $10 of benefits, but at a cost of $20. So if we're spending $20 to add $10 of benefit, the net cost is that we are $10 poorer per ticket. So that's more deadweight loss. We're adding more to the cost than we're adding to the benefit. We're just changing the form. If you think about minimum wage laws, a story that you will see is people estimate that the unemployment effect of minimum wages are overstated. But what explains that is that as we increase the minimum wage, we get rid of fringe benefits. So there was a story in Seattle when they raised their minimum wage to $15 an hour that airport workers no longer got free parking. They had to pay for their parking to go to work. So the net effect was they got more per hour, but they also were facing this extra cost. Now, free parking is something that would be relatively cheap for an employer to offer, and if it's something that is lowering the cost of supplying your labor at a relatively low cost, right? If it's adding $10 cost to the cost of employment, but it's adding $20 of value, or reducing the employee's cost of going to work by $20, then the result is you're doing something that makes sense. You're spending a small amount of money to create a large amount of value. But if we require that you pay your employees a high price, you got to find corners to cut, and sometimes you end up cutting corners that aren't worth cutting. So that to say, just because we don't see an unemployment effect or we don't see excess supply doesn't mean that we aren't facing some economic consequence of a price control. All right, let's stop there. And I'll do another short video where I work through this, but I will make that sort of an appendix video.